indirect proof, you start with assuming by hypothesis is true. This is k 2m plus 1. L means 2n plus 1. If n square is even, then n is even. Assume that n is a odd integer. Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my previous session, I have discussed the problems on rules of inference. So today I will discuss the new topic called indirect method. What is this indirect method or indirect proof in logic? So indirect method. Usually in a direct proof, you start with assuming by hypothesis is true and make one decision and after another until the condition. So in direct proof, we are assuming the hypothesis is true, but in indirect proof, we are assuming the hypothesis is false. That's it. So the notation of inconsistency is used to drive a proof at times, and this procedure is called as indirect method or indirect proof or proof by contradiction. So in direct method, we are assuming the hypothesis is true, but in indirect method, we are assuming the hypothesis is false. This is called as indirect method. So now let us understand about the topic with an example. So if it is false means we are deriving it is a true. The condition is true. That is called as indirect proof. If you get a true condition, so finally we will conclude that it is a false. So that is called as indirect proof. Clear? So first example problem on indirect method. So here, this is very important question. You can expect this question for 7 marks. It is compulsory question. So prove that for all integers k and l. We have two integers called k and l. If k and l both are odd, if k and l both are odd, then k plus l is even. K plus l is even and KL is odd. KL is odd. So we have to prove with the help of indirect method. So here we have two integers, that is k and l, both are odd and k plus l is even and KL is odd. We have to prove that both are even. Clear? So here first I will consider. So what is this even and odd? Here you have two integers called k and l. So we have to prove that both are odd. And k plus l they have given and KL is given. So now we have to prove that k plus l is even and KL is odd. So what is this even and odd? If it is even, you will get 2 into m or 2 into n, any integers. And if it is odd, even plus 1 is equal to odd. That means 2m plus 1 is equal to odd. So if it is odd means you will get this type of answer, even plus odd. If it is even, you will get 2 and any integers called m, n, etc. Even means 2m, odd means even plus 1 is called as odd. So now I will use this concept and I will prove that k plus l is even. So now I will consider. So first assume that k and l are integers and k and l are odd. Both are odd. So now first I will take, let k is equal to 2m plus 1 and l is equal to 2n plus 1. So why I am taking this k is equal to 2m plus 1, l is equal to 2n plus 1. If you want, you can interchange this. K is equal to 2n plus 1 also you can take and L is equal to 2m plus 1 also you can take. So now I am considering K is equal to 2m plus 1, L is equal to 2n plus 1. So first I will find out k plus L is even. So now k plus L. So what is k plus L? 2m plus 1 plus 2n plus 1. 2m plus 1 plus 2n plus 1. This is k, 2m plus 1. L means 2n plus 1. So now I will add these terms. 2m plus 2m plus 1 is 2. So now you can observe this. 2 is common here. So I will take 2 as a common factor. M plus n plus 1. So now this is in the form of 2m, right? So this you can consider as m. So 2m. This is in the form of 2m. So k plus L is even. So what is the question? K plus L is even. We have to prove that k plus L is n. So we got k plus L is even only. So therefore k plus L is even and it is divisible by 2. And it is divisible by 2. If it is even means it should be divisible by 2, right? So now we got 2m. So k plus L is equal to 2m. This is your answer. So 2m means what? We can consider it is a even number. So odd means even plus 1. Plus 1 means it is odd value. Now I will prove that KL is odd. So KL means multiplication. So I will prove KL is odd. So k into L. You just multiply these two. K means 2m plus 1. And L means 2n plus 1. So 2 2s are 4 m into n plus 2m plus 2n plus 1. Now I will take 2 as a common factor to this 3 terms. 2m n plus m plus n plus 1. So now you can cross verify this. It is in the form of even plus 1. Even plus 1 means 2 into m. This is I will consider as m or n. 2 into m or 2 into n plus 1. So 2m means it is even. Even plus 1 is odd. So this is in the form of 2 into m plus 1. 2m plus 1 means it is odd. So therefore KL is odd and k and L are integers. And k into L is not divisible by 2. Clear? So k into L is odd and it is not divisible by 2. If it is odd means it should not divisible by 2, then only we can consider as it is a odd integers. And k plus L is 2 into m, that is divisible by 2. And k into L is odd, it is not divisible by 2. So this is your final. So this is your solution. It is a indirect proof. So here we have integers, 2 integers, that is k and L. If k and L both are odd, then k plus L is even, KL is odd. So we have to consider 2 integers value. Example, k is equal to 2m plus 1 or k is equal to 2n plus 1 and L is equal to 2m plus 1 or 2n plus 1. So you can assume the integer value and substitute to this integers, that is k plus L is even, KL is odd. So this is your proof. And the next question is, provide a proof by contradiction of the following statement. So here we have one statement. For all integers n, if n square is even, then n is even. So here they have mentioned that we have to prove this by contradiction of the following statement. Here they have given the statement as if n square is even, then n is even. Here I will prove this by contradiction because they have mentioned it has to be proved by contradiction of the following statement. This is your given statement. So I will prove this by contradiction. What is the contradiction of this statement? Contradiction is for all integers n, if n square is odd, then n is odd. So this is a contrapositive or contradiction of the given statement. So in given statement they have mentioned that if n square is even, then n is even. But in contradiction means if n square is odd, then n is odd. We have to prove this by contradiction. Clear? And now I will prove this by contradiction. If n square is odd, then n is odd. We have to prove this. Let n be any integer. Let n be any integer. So now I will prove that n square is odd. N be any integer, then n square is odd. So now by definition of odd, so what is the odd definition? By definition of odd, n is equal to 2k plus 1, right? So in previous problem I have considered 2m plus 1 as a odd value. Now I will consider n is equal to 2k plus 1 and for some integer k. For some integer k. So now I have considered by the definition odd is n is equal to 2k plus 1. Clear? So now I will prove that n square is odd. If n square is odd, then n is odd. So now I have considered n is equal to odd. So now I will prove that n square is equal to 2k plus 1 whole square. Clear? So what is 2k plus 1 whole square? This is in a form of a plus b whole square formula, right? So a square plus b square plus 2ab. 4k square means a square, 2k whole square means 4k square plus 1 plus 2ab. 2 into 2k plus 1. So 2ab. So now you can rearrange this first 4k square plus 4k plus 1. So now again you can take common factor as 2 as a common factor. So 2k square plus 2k plus 1. So now this is in a form of odd, right? Why it is in a form of odd? So by the definition, odd n is equal to 2k plus 1. So now this is in a form of 2k plus 1, right? So now it is a odd equation. So it is not divisible by 2. So if n square is even, then n is even. But now I am proving this statement by contradiction. So if n square is odd, then n is odd. So n is odd and n square also odd. So by odd definition, 2k square plus 2k is an integer. Therefore, n square is odd by definition. N square is odd by definition. So with the help of this contradiction, we have to prove this statement. But here the statement is even, but we have proved this by contradiction. So we got n square is odd by the definition. So this is your proof by contradiction to the given statement. So now the next problem is provide a proof by contradiction of the following statement. Again the same question, but here we have if n square is odd, then n is odd. Same problem, but here we have the given statement is odd. We have to prove that by contradiction. So given statement is even. Let n be an integer. Let n be an integer. Then the given statement reads P implies Q, where P is n square is odd and Q is n is odd. So here we have to prove that n square is odd, then n is odd. But by contradiction, we have to prove that n square is even. Assume that P implies Q is false. P implies Q is false means what is the truth table form? If P is true and Q is false, so obviously P implies Q is false. True implies false. True implies false means we will get false only. Then n is true. If P implies Q is false, then n is true. N is true means it is a even. So n is even. So Q is false means n is not an odd, it is an even. Clear? So now I will consider n is even. So here I got even statement. So n is even means I will take n is equal to 2k. So now prove that n square. So n square is equal to 2k whole square. 2k whole square means it is 4k square. Clear? So 4k whole square means again I can split this 2 into 2k square. So now this is in a form of 2 into m or 2 into k. So 2 into k is equal to n. So it is divisible by 2. It is divisible by 2 means n is even. It is divisible by 2 because we got the even value. So n is equal to 2 into 2k square. So n is equal to 2k. N square is equal to 2 into 2k square. So n square is even. Clear? And again I will consider odd value 2k plus 1. If n is equal to 2k plus 1, what is n square? 2k plus 1 whole square. This is in a form of a plus b whole square formula. So 4k square plus 1 plus 4k. So rearrange this 4k square plus 4k plus 1. So now I will take 2 as a common factor. 2k square plus 2k plus 1. So now this is a odd integer. So now n is a odd integer. So now from our assumptions, if P is true, then P implies Q is true. So this is your proof by contradiction. The given statement is in odd condition. So we have to prove that n square and n is even. And the next problem, give a direct proof, indirect proof and proof by contradiction for the following statement. So here we have to prove that given statement with the help of direct proof, indirect proof and proof by contradiction. We have to prove this 3 conditions we have to prove for a given statement. So what is a given statement? If n is odd integer, then n plus 9 is even integer. If n is odd integer, then n plus 9 is even integer. So first I will prove this by direct method. So first is direct proof, second is indirect proof, then it is proof by contradiction. So first I will prove this by direct method. So here first I will take n is odd integer. So first method is direct method. First I will consider, assume that n is a odd integer. N is a odd integer. Then n is equal to 2k plus 1. Because it is a odd integer, the given statement is odd integer. So I am proving this by direct method. So as usual, I will consider n is an odd integer. So n is equal to 2k plus 1. So now we have to prove this n is odd integer, then n plus 9 is even integer. So add 9 on both the sides. So n plus 9 is equal to 2k plus 1 plus 9. So now add these two factors, 2k plus 10. So again I can take a common factor as 2 k plus 5. So this is in a form of 2 into k. So 2 into k means it is divisible by 2. So n plus 9 is equal to 2k, 2 into k plus 5. So n is even. N is even. Clear? If n is even means, so q is true. So n is even. So this is proved by direct method. So first you have to consider the statement n is odd integer. So consider the statement n is odd integer. So here I have assumed n is equal to 2k plus 1. So now you have to prove that n plus 9 is even integer. So add 9 on both the sides. N plus 9 plus 2k plus 1 plus 9. So it will become 2k plus 10. So n plus 9 is equal to 2 into, take as 2 as a common factor, 2 into k plus 5. So here n plus 9 is equal to 2 into k plus 5 2s are 10. So 2 into any value, 2 into m or 2 into k is divisible by 2. So it is a even integer. So we have proved this by direct method. So next, what is the next method? So the next is indirect proof. So given statement is if n is odd integer, then n plus 9 is even integer, right? So we have to prove this by indirect proof. So here the given statement is n plus 9 is even integer. So we have to prove this by indirect proof. Then n plus 9 is not an even integer. Is not an even integer. It is a odd integer. So here n plus 9 is equal to 2k plus 1. It is a odd integer. If it is not a even integer means there it should be a odd integer. So 2k plus 1. So n is equal to 2k plus 1 minus 9. Just cross multiply this 9. So you will get 2k minus 8. So n is equal to 2k minus 8, 2 as a common factor. So 2 into k minus 4. So now it is divisible by 2, right? So n is even integer. So this is proved by indirect proof. And the last one is, so proof by contradiction. We have to prove that if n is odd integer, then n plus 9 is even integer. So assume that P implies Q is false. If P implies Q is false means P should be true and Q should be false. Then only we will get false condition, right? So this is implication truth table. P implies Q is false, then P is true, Q is false. So now we have to prove that n is odd integer, then n plus 9 is even integer. So n is odd, then n plus 9 is odd. So here they have given n plus 9 is even integer, but we are proving this by contradiction. So n plus 9 is odd. Therefore, n plus 9 is equal to odd means I will take 2k plus 1. So n is equal to what? 2k plus 1 minus 9. So it is 2k minus 8. 2 is a common factor. So it is k minus 4. So n is equal to 2 into k minus 4. So 2 into k, 2 into m means it is divisible by 2. It is a even. So n is even integer. If it is even means P is true, Q is false. Therefore, contradicts the assumptions as n is odd. Therefore, the given statement is true. Clear? So, this is your proof by contradiction and direct method and indirect method. It is very simple concept. You can expect this question compulsory for 4 marks or 7 marks. So, this is about your indirect proof. So, there will be a problem on this topic. Please practice all the problems. So, in my next session, I will come with a new concept called quantifier. Thank you.